Thank you both very much for joining us. So good morning, everybody. Welcome to today's webinar. I'd like to thank everybody here in attendance. We certainly appreciate your time today. For today's webinar, the MMDA has partnered with Global Automakers of Canada and Volkswagen Audi of Canada to give Manitoba Public Insurance an overview of what can be expected for repairs to zero emissions vehicles from the perspective of the manufacturer. We have seen growth in this sector with zero emissions vehicles making up more than 5% of motor vehicles registered in Canada in 2021. The expectation set by the federal government on this is that by 2026, at least 20% of new vehicle sales will be zero emissions. This grows to 60% by 2030 and 100% by 2035. This mandate became law in June 2021. We have seen the response from the manufacturers, with all major manufacturers releasing new zero emissions vehicles. This will be a rapid change for the automotive industry, and we hope that the information that you see here today can assist MPI and increase awareness on the expected standard for safe and proper repair for zero emissions vehicles. The MMDA proudly represents franchised new car and truck dealers across Manitoba. Our members employ over 6,500 people and generate $2.6 billion annually to Manitoba's economy. MMDA operates throughout Manitoba. Our primary office is located on Treaty 1 and the homeland of the Métis Nation. Our work extends throughout Treaties 2, 3, 4, and 5. We acknowledge that Winnipeg's water is sourced from Shoal Lake's 41st Nation. We respect the treaties made on these territories. We dedicate ourselves to move forward with Indigenous communities in the spirit of reconciliation and collaboration to make Manitoba an inclusive and safe place for everyone that lives here. So moving on to introduce you to today's speakers. We're honored to have Andrew McKinnon. Andrew is with Global Automakers Canada and has been there since 2018, serving as the Director for Provincial Affairs and Outreach since 2022. His responsibilities include facilitating the work of the association's government, policy, stewardship, and logistics committees. Andrew has been leading the association's work on electric vehicle battery policy, provincial resource recovery strategies, and Canada-wide logistics issues. We also have today with us Scott Wildman. Scott is the Collision Program Manager for Volkswagen and Audi in Canada. With more than 25 years experience in the automotive sector, Scott has spent 19 years in various dealer after-sales roles in 9 different automotive brands. In his current role, Scott is responsible for the collision program development and implementation for Volkswagen and Audi, and is focused on working with stakeholders to improve the repair process with consumer safety as a top priority. A key focus for Scott has been to support the collision repair sector of Skills Canada by dedicating time to educate students on body technology advancements to attract youth to pursue a career in the collision repair trade. He's an avid English football fan and resides in Pickering with his wife, Joanna, and his 2 sons. So without further ado, I will hand this over to Andrew, our first speaker. So Andrew, the floor is all yours.
Thanks very much. Happy to be here to be speaking with the folks from MPI as well as your members at the Manitoba Dealers Association. My presentation will be pretty short today. Just provide some overview on practices as we see from our members in the repair and treatment of electrified vehicles. So I'm just going to pull up my presentation deck here. As I said, so for some background, Global Automakers of Canada, we represent 15 major vehicle manufacturers, global manufacturers, of course. 2 of our member companies are manufacturing vehicles here in Canada and Ontario. Lindsay and the MMDA approached us to asking, what sort of things are happening amongst our member companies as far as the treatment and repair of EVs in Manitoba. So we did carry out a survey of our members, and I think the general thing that we'll see, and we look at how early we are in the stage of electrifying the vehicle park in Manitoba. And we're at a point now where the certification and training for EV repair is very focused on the dealer networks and dealer repair shops. This is something that all of our OEMs who responded to our survey, which was about half of the GAC members, indicated that volumes are increasing for EV sales in the province, but really now it's still a niche expertise for the maintenance, repair of those vehicles, particularly the batteries. And that's taking place at the dealerships where technicians have been trained and certified for that. And there are, various plans to start to roll out the opportunities for that training and certification to the non-dealer network, the third-party collision repair centers, et cetera. But it's still very much early days. You can see here some indications on the costs that are being implemented or undertaken by the manufacturers to have their dealers equipped to diagnose, repair, and treat those more advanced technology vehicles. Some measures being put in place to mitigate the costs of that for individual dealers, but still, as I've noted a couple times, it's something that we can't really estimate for the third-party repair centers what those costs will be when the opportunity comes for them to have that training and potentially rolled out to them. But there are additional costs now to treating these vehicles with the requirements to diagnose, especially as you'll see in Scott's presentation afterwards, treatment of batteries in advanced vehicles. So of course, just some final comments. We're just seeing an increasing offer of electrified vehicles in Manitoba, battery electric, plug-in hybrid, and hybrid vehicles, more and more every year. All of our OEM respondents indicated that the training for certification and repair of these vehicles is so far in-house for their dealer technicians, and that eventually in the future we'll start to see that offered elsewhere. Some final thoughts. I think, as I mentioned, statistically, I don't have it up on the board, but looking at the Stats Canada information for zero emission vehicle sales in 2021 in Manitoba, there were 356 full battery electric vehicles registered. So that's about 0.8% of all new vehicles registered in the province. And when we expand that and start to think of other electrified vehicles, hybrid, plug-in hybrid, you get about 2,500 vehicles, or 5.5% of all the vehicles registered in the province. So Manitoba does well, not as same percentage level as some of the provinces with incentives in place like Quebec and BC. And just for some perspective, looking back to some of the pre-pandemic numbers in 2019, those BEV, FEV, and hybrid vehicles only accounted for 1.7% of vehicles registered. So we are seeing an arc on the upswing. It's something that I think all of the manufacturers are starting to look very seriously how those vehicles will be treated. And I think Scott's presentation is going to give you all a great in-depth of the actual considerations that have to be made. And I hope that some of our comments here from the GAC side, and you can see the membership of our association here, have shed some light kind of on the overall industry perspective. So thanks very much for your time. I imagine, Lindsay, that we'll do kind of a Q&A at the end. So I'll look forward to some of your questions then.
Thank you so much, Andrew. Scott, the floor is yours, my friend.
Perfect. Excellent. Well, thank you for this opportunity, and good morning to everyone. I was just thinking, Andrew, as you were finishing your presentation about zero emission vehicles really starting to take off. Aren't they going to take off with today's gas prices? Isn't this on the tip of everyone's mind when we're at over $2 a liter? So I can tell you from our manufacturer side, obviously for many years now, the Volkswagen Group has been demonstrating they're very committed to high voltage vehicles and increasing the electric vehicle car park, right? So today's presentation, as Andrew alluded to, is to kind of give you an overview of all the considerations that go into the production of an electric vehicle, construction-wise. We're going to look at how that vehicle needs to be handled in a post-collision incident. And those considerations, which are detailed in our repair literature, as with most manufacturers, is probably going to lend itself to many discussion points amongst, the group at MPI, for example, and even the Dealers Association in Manitoba, right? Because there are some, safety concerns when we're dealing with high voltage. So to get into it, I'm going to share my screen. Just make sure that this setting for audio is set. Okay, it is.
Scott, we can't hear you.
And why is that? Now, can you hear me?
Yep.
All right. Perfect. So when we're talking about high voltage vehicles, and I'm going to use this interchangeably, electric vehicles, high voltage, you're looking at one of the main presentation slides here, and you can see the kind of environment where diagnosis and repair needs to happen. And when you're looking at the way this technician is actually outfitted, the kind of materials and PPE that he has, obviously non-conductive materials, the safety considerations that have been put in place by Audi, but most likely most manufacturers, is, to go to the extreme level in preparedness. And then we can ensure that, technician safety is kept paramount. For this presentation today, just a brief disclaimer. This is just a presentation about an overview of Audi electric vehicles, what the repair considerations are. It's not representative of all manufacturers. However, a lot of the technologies are very similar in concept. So I want to make clear that if any clarification is needed for other brands or models, then you'd need to consult that respective OEM. So as far as an agenda, what we put together today was going to look at battery safety, look at the actual battery construction, what a high voltage vehicle looks like from a construction standpoint, then get into what high voltage vehicle procedures are, what the training requirements are, and then what some of the repair processes are. So to introduce what a high voltage vehicle construction looks like, but also the safety that's gone into safety considerations into these vehicles that have been produced, I've got a video that I'd like to share. And it's going to be pretty enlightening. as you could see in that example of the e-tron, there's obviously a lot of engineering that's gone into safety and making sure that we keep the occupant cell as safe as possible, as well as to protect the battery unit within the vehicle in the event of a crash. So along those lines, from a vehicle construction standpoint, notice that the high voltage battery is fully integrated into the load bearing structure of the car. So the considerations when it comes to vehicle repair, especially structural repair, are absolutely critical that the manufacturer's guidance be followed and that the right equipment and including the correct bench that is met, because obviously the tolerances on a high voltage vehicle is we need to make sure that post structural repair, those 37 bolts will actually line up and be able to bolt this battery back into the chassis. So, you know, the manufacturer's requirements will be very, very specific on how these need to be repaired. And you'll notice in the bottom left-hand corner, it shows you a little bit of the engineering that's gone in to provide the crash protection that you saw in the video through extruded castings. This is an aluminum assembly that protects the battery, but also increases the torsional rigidity of the chassis. So here's an example of the high voltage vehicle procedure, and this bulletin's in our literature specifically related to when a vehicle's in an accident. So I highlight the area in red. You'll notice as a process, it first starts out with that the high voltage technician, which is only at the dealer at this point, must be informed when an accident damaged vehicle is being delivered to the workshop. So these collision centers need to make sure that they're in step with their local dealer on making sure that these processes are followed when they're receiving a vehicle. Some of the considerations when you're looking at this bulletin's 3 pages long, but it gets into the process of what needs to first take place before anybody touches the car. And that starts with classifying the vehicle, the battery condition, and whether there is a critical fault in the battery or even something worse. That's before we can even start doing an estimate on the car, right? So it's imperative that the industry be prepared for this, because it's going to change the approach on vehicle reception and immediate diagnosis before you even start thinking about creating an estimate on the car. And I can't stress this enough, because although it might not be an issue maybe in Manitoba, I know of examples that I've been involved in where even our mild hybrid vehicles, there's a Q5 that I'm aware of that went into a non-certified collision center, had been in an accident, and there was a warning light on the dash about the battery system that needed to be addressed. Well, the collision center didn't follow the literature. They proceeded with the whole estimate and approval process, repaired the car completely, and then sent it to the dealer to address the battery symbol. And it turns out that the battery was critical. The battery needed to be replaced. And so they've done all the repair structurally to the car, and now it needed a battery, which turned out to write the car off because of the cost of the battery. So, you know, it's pretty critical just from an economic standpoint for the insurer that this is followed to the letter, right? Instead of incurring all those costs to repair a car and then it be totaled afterwards. I just point out too, this bulletin starts off by saying what the reception process needs to be with the high voltage technician. It goes further to say after classification, the vehicle may need to be quarantined away from buildings, away from other vehicles, other infrastructure. And in the case where the battery might be critical, the battery temperature must be measured multiple times per day for 5 days. This is before anything you do with the repair process can get started, right? So the classification process is absolutely critical. And what we use, as you see here, is essentially a traffic light symbol as far as what our literature dictates, how the car needs to be addressed. And the high voltage technician will classify this. And depending on battery condition, that will be our next steps on how we may be able to proceed. Now, one thing that was pointed out to me previously was, what are the considerations when accident vehicles are being towed from an accident scene? And, the tow operators might not be, totally in step with what, our literature says and what the requirements are. So obviously, in a towing incident, using this from our literature and the classification matrix, any of the items that may appear in the danger category, so that can be obvious signs of physical damage to the battery, leaking fluids, smoke, crackling noises, and the obvious ones such as ignition or a fire event. At that point, that needs to be the all stop process with a tow operator. They're not to touch the car. No one is to touch the car if it's in those conditions, right? And at that point, even depending on whether necessary, the fire department should be called and be involved, right? So it's absolutely critical that industry, comes up to speed with what's required in handling these vehicles. When we're talking about the repair process itself, there's a lengthy section in our literature that talks about what the process is that must be followed when you're doing any type of repairs on the car. So you see highlighted in red, if you're doing any body repair, welding, separating procedures near high voltage components, the car must be de-energized by the high voltage technician. If you put the car on a frame machine, the car must be de-energized. So it's going to be critical, and you'll see in a later slide what that relationship in the whole repair process environment is going to be. That interaction between dealer, the high voltage technician, and the collision center. They must be in lockstep on how to handle these cars correctly. So when we're talking about training, in our world, there are 3 training levels. The first is being high voltage aware, or EIP is electrically instructed person. This is general knowledge just about what high voltage components look like, orange cables, etc. It's an awareness course. This individual would not have any instruction on how to handle the car or repair the car. So positions that this would apply to would be your estimators, your CSR people at the collision center, your receptionists even. In our dealer network, we've made the whole dealer network go through this type of training so that they understand what is required. For our collision centers, we are going to be developing a platform where they can access the same learning material as the dealer has, because it's absolutely critical. So when we were talking about before, high voltage technician, HVT, that's more in-depth training. They will be trained to run diagnostics, de-energize the system, and also be involved in removal of the battery assembly itself, and reinstallation, re-energization as needed. Now, the high voltage expert, they are trained in all systems, including internal battery repair. So if you cast your mind back to the introductory slide, that's the high voltage expert in the full outfit, working in a controlled, clean environment. They are the ones that have been trained to actually conduct internal repairs on a high voltage vehicle. So we alluded to before what that repair process evolution needs to work towards. And I think this is a critical slide for the industry and for MPI, is the repair process is going to change and has changed. So if you're looking here in kind of a closed loop scenario, it starts when the vehicle's in an accident and goes to a body repair shop. However, that car may need to move at up to 3 times back and forth between the repair shop and the dealer for the body repairs to be conducted. So if you think about it, if there is anything required structurally for repair and the battery has to come out, vehicle needs to be flatbedded to the dealer. They de-energize the system, and also remove the battery, return the chassis back to the collision center. They can complete their structural repair, and then the vehicle's then sent back to the dealer for reinstallation of the battery, re-energization, calibrations, right? And making sure that everything's okay, right? So this whole repair process is going to change significantly, and the insurers need to be, aware of this. Obviously, there's additional costs in moving a car back and forth, but this is the introductory stage, let's say, because it's really not feasible, and you'll see that in later slides, to have all the collision centers trained and equipped across all the various manufacturer brands to be able to handle this technology, especially with such a small car park to begin with. In the future, we see the development where additional training and certification requirements would be granted to collision centers, but at the beginning, this is the new normal that everybody needs to be aware of, right? And those increased costs, even at an actuary level, need to be taken into consideration. So you'll notice there's a final note there. We put out a bulletin that's saying for minor damage, we've instructed the dealers to send their high voltage technician with the appropriate equipment, diagnostic laptop, etc., to the body shop to classify the battery and de-energize as necessary. So that way we can avoid the movement of a vehicle back and forth, the increase in cycle time that it's going to lead to, and also increased costs. If it's something that's minor in nature, then we'd like to try and address it proactively. So when we're talking about when a vehicle is first received at a collision center or a dealer, here is an example of what a quarantine area needs to look like. And if you're looking at, especially over here, as far as distances, our literature is very explicit in stating, there needs to be 16 feet on either side all the way around of the car, and an internal quarantine area that only a high voltage technician or expert is allowed to go through. Okay, if that person is not trained, they are not to enter that internal quarantine area. And so you clearly get the sense of what the reception process needs to be, to protect, infrastructure, buildings, other vehicles. It needs to be in an out of sight area, so that the general public and customers aren't seeing it. That it needs to be over a properly sealed workspace, and also that there's a drainage tray should the case have been cracked in, the coolant fluid for the battery system perhaps is leaking, right? So, it's absolutely critical that the industry be prepared for this type of approach. Here's an example of what the high voltage expert workstation would look like. And in the next couple slides, it's really going to drive home the point where, at least for the Volkswagen Group, this type of repair will remain with the dealer because of the complexity, the tooling involved, the training required, and that's only for our two brands. And imagine how collision centers would need to try and make all those investments in training and tooling for all the brands that they fixed. It's just not going to be possible at the beginning. But you get the sense of what the workspace looks like as far as equipment wise. Also, the cleanliness of that workspace is paramount when we're dealing with high voltage repairs. So again, the internal repair area has an outer cordon area, and as well has an internal area that's cordoned off where the high voltage expert is conducting those repairs. So some of the examples that drive home the point of how specialized a lot of the equipment is. And this is just, for example, on the e-tron. This isn't cross-functional across many of our models yet. And I'm looking to see if that does become more of a homologated approach, for the best term to use, where there's a lot more cross functionality in some of the equipment. But look at how individualized, just to remove a battery out of its shipping case, to raise it up and put it on a battery table, the hoist assemblies that are needed. And this is just for our brands, right? What about all the other manufacturers? The complexity that's involved is very apparent. A very specialized battery tray system to raise and lower the battery. And you'll notice in the next slide, there's even fixture assemblies for this chassis, so that we make sure that this battery is completely and securely locked down before it is lowered and moved to the area where the battery repairs will need to be conducted. So you can see, there's a lot of specialized equipment required, and which adds to the complexity for collision centers today, to be even considering entering this space. It's just not going to be feasible. But one thing to note, how this is really going to change things as well, at least for our brands, the dealer standards had to change on simple things like hoists. So your hoist to raise and lower the car to get the battery tray device below it, the now minimum recommended width is 67 inches. Recommended is 70 inches wide. And I can tell you, there are probably no shops that meet that standard, right? Our whole dealer network had to upgrade, right? Because, this is a new consideration with, the vehicle technology, how it's been constructed, and these battery trays are quite big, right? And you need enough tolerance and space to get this lift unit underneath, so you can lower the battery and take it out of the car, right? So there's additional complexity in the process there. And then kind of finally, from a repair process standpoint, again, if you think about that introductory slide with all the protective equipment that individuals are using, clearly the PPE requirements are very strenuous, right? And we want to make sure that these individuals are absolutely protected. So I'm sure one of the questions that is probably coming up is, what does the future look like as far as EV adoption, volume, car park increases? When is that going to happen? What's it going to look like? Well, from our standpoint, the Volkswagen Group, believes globally that 2028 will achieve um, the 50% threshold of EVs produced compared to combustion engine. So that's not that far away, to be honest with you. And uh, kind of our measuring line is Norway, which, if you're not aware, is a country that has been very aggressive in adopting a zero emission vehicle policy. Actually, 2025, they've set their marker down that all vehicles need to be zero emission. So in 2021, they've already achieved 65% ZEV sold in the market, and an additional 22% of that were plug-in hybrids. That left only 14%, which were combustion engine. So you can see how a market can develop. And what goes along with that is what you're thinking is, what is the infrastructure become to support that, especially on the collision center side? And I can tell you our Norwegian colleagues have trained their certified collision centers to that high voltage technician level that you saw in the training tab. And so what that means is they're able to diagnose, classify a battery when the vehicle actually comes in. The dealer doesn't need to be involved. They're trained to that level to do those functions, and then also, as necessary, remove the battery, reinstall, re-energize. So the critical functions as part of a collision repair loop, in the future, we see our certified network achieving that high voltage technician certification level. And then only if a battery needs to have internal repair done to it, would it then have to go to the dealer who has that certification level to repair that in a collision incident situation, right? So, but again, volumes need to increase to justify this, especially from a training and equipment investment. And that too is just for our brands and our certified centers. And so I think it's going to become very apparent that there's going to be some degree of specialization because body shops really, in this kind of environment, can't be all things to everyone, right? There's going to be a need for specialization, which the technology is going to dictate. So what does this all lead to? Kind of as a summary, we are facing a major technological shift in the automotive industry, like one that has not been seen in 100 years since the introduction of the car. And it's going to change the landscape considerably on how we address vehicle repair. So obviously, we need to make sure we have the procedures in place by that respective OEM, the proper equipment that is necessary for repair of that car, training, and also process, so that we can make sure that we look after our customers, our mutual customers, in the best way possible and deliver the best experience in restoring their vehicle to a pre-accident condition, and to do so safely all along that journey, right? So some of the considerations for MPI and industry, what does it look like? And you need to really start thinking about this. What happens in the event of an accident, and if there is a collision inspection yard that MPI controls and those vehicles first go to, how are those vehicles being stored? What is the process to ensure there's a quarantine area? And obviously, any of the conditions that would lead to more serious battery condition events, what is the process to make sure that is looked after? Even in the salvage process, if a vehicle is a total loss, how are those vehicles being addressed? What about at the final stage, even in a total loss and it's an end of life situation? The thoughts need to be given to what is going to happen with battery recycling as well. So along those lines, I can tell you that the Volkswagen Group in Canada has partnered with Li-Cycle, and they are an international battery recycling entity that can handle EVs, EV battery assemblies, and they will be handling our recycling efforts. And we've already been on this pathway for a number of years now, as electric vehicles have been in our market for some time, even the hybrid vehicles as well. So those are some of the considerations that that MPI needs to really put into focus now, so that you can prepare for what is coming and quite rapidly from a volume perspective as far as electric vehicles go. So I thank you for that opportunity to present what our vehicle technology is and some of the considerations for that. And I'm sure, I guess at this point, I'd open it up to you, Lindsay, on what the next steps, Q&A, whatever might need to take place.
Thank you so much, Scott. That was really informative. We appreciate it. To the attendees, I did send out a message. If there are any questions, please use the chat function. We'll just give you a few minutes here to see if there's anything to be asked from those that are attending to the panelists. If at this time there is in fact nothing, I know that was a lot of information. You can please feel free to reach out to me at any time. We can certainly get your questions answered. It doesn't necessarily have to be right at this moment either. So far, seeing none. So again, just thank you so much to both of you, to Scott and to Andrew, for your time today. The information was incredibly informative, and then hopefully for those in attendance from MPI's perspective, that this information was useful in terms of what to expect for proper and safe repair of zero emissions vehicles. Still seeing no questions here. Other than the slides, I can certainly.
The slides will be able to be shared from my perspective. They'll be shared as a PDF.
Perfect. Okay, so I definitely will distribute the slides to all of those in attendance today. If there are no further questions, then thank you both for your time and for your information. It was incredibly informative, and we'll leave it there.
Thanks very much, Lindsay. Thank you, Scott.
Thank you.
Take care, guys.
For the opportunity. Bye now.